Hello friends, this is lecture number 6 of integral transformation, and today here we're going to discuss about convolution theorem. Okay, so we're going to discuss about convolution theorem, right? So before we start, please subscribe the channel, hit the thumbs up button, also share with your friends, help me to grow my channel, inspire me to create new contents for you. So now let's start. So before we discuss that convolution of convolution theorem of Fourier transform, first we must know what does convolution mean. Convolution of two functions. Let me write the definition. So convolution of two functions f of x and g of x is defined as f of x, the convolution represented by the star g of x, integration from minus infinity to plus infinity f of u, that should be u actually, just wait, here we should write u, f of u, g of x minus u du. This is the definition. Now what is the convolution theorem for Fourier transformation? According to that theorem, convolution theorem for Fourier transformation, the Fourier transformation Fourier transform of the convolution of two functions, suppose f of x and g of x. This is given by the product of their Fourier transforms, right? So that means Fourier transform of f of x convolution, f of x and g of convolution of f of x and g of x. Suppose we need the Fourier transformation of the convolution of f of x and g of x. In that case, this is given by Fourier transformation of f of x into Fourier transformation of g of x. Or you can write Fourier transformation of f of x is let it be suppose f of s, and Fourier transformation of small g of x is suppose let me take capital G of s, right? Capital G of s, okay, where we can write that capital F of s is the Fourier transformation of small f of x, and capital G of s is the Fourier transformation of small g of x, right? So we can consider that way. So now let's prove. Let me go to the new slide and let me prove that. So we know that the definition of convolution, that is, we have already got that a convolution of these two functions is given by this integration from minus infinity to plus infinity f of u g of x minus u du, right? That's what we have already got. Now let us take the Fourier transform of both sides. Okay, if we take the Fourier transform of both sides, then what we're going to have? We're going to have on the left hand side this Fourier transform of convolution of f of x and g of x. On the other side, Fourier transformation of integration of this, right? So now what we can do, according to the definition of Fourier transformation, we should get this one, right? Let me tell you how. What is the definition of Fourier transformation? Fourier transformation of a function f of x is equal to integration from minus infinity to plus infinity e to the power minus I s x f of x dx, right? This is the definition. So here this f of x is represented by this part, right? This integration. This is e to the power minus sx, and integration from minus infinity to plus infinity dx, right? So hope you have understood this. So now what we can do here you see integration f of u du, we can write, then integration minus infinity to plus infinity g of x minus u, then e to the minus sx dx, we can write that way. So this is the Fourier transformation of convolution of these two functions. And let me go to the new slide. Here you see what we have got in the last step we have written here. Let me write that last step we have obtained in the previous page. Okay, so here putting x minus u is equal to t or we can say t is equal to, sorry, x is equal to t plus u. So if you differentiate both sides with respect to x, then you're gonna have t dt is equal to dx, right? You can check yourself. If you differentiate this with respect to x, that's gonna be 1. If you differentiate t with respect to x, then that's gonna be dt du dt by dx, and here it's gonna be 0. So dt is equal to dx. That's what we're gonna have, right? So hope you have understood this. So now just do it. Now you see, so here x minus u replaced by t, okay, and f of u du. Here z of t we're gonna have, because x minus u, this is replaced by t, right? So then e to the power minus s x, instead of x we're gonna have t plus u, right? T plus u. Then dt is replaced, dx is replaced by dt. So here we're gonna have dt. Then it can be written this way. So e to the power minus is t plus u, that can be written as e to the minus ist into e to the minus isu du, sorry, dt. So then we can write this way. Now you see, let me tell you one thing. Suppose you need to integrate, let me take just x dx. Then what are you gonna have? Then you're gonna have x square by 2, right? And if you integrate y dy, then what are you gonna have? Y square by 2. For different variables, we are getting different results of the same form, right? So now you see, if suppose you have to integrate it from 0 to 1, suppose this is also 0 to 1. Now in this case, though these variables are different, but you're gonna get the same values, because here upper and lower limits are same, right? If that's gonna be 1 square by 2 minus 0 square by 2, that's gonna be 0, right? That is half. So here also you're gonna have 1 square by 2 minus 0 square by 2, that's gonna be 0, that is 1 by 2. So same answer we are getting, right? So similarly here also, here you can see only variables are different, but upper limits, lower limits, both are same. So we're gonna have the same result. That's why we can replace them by a common variable. So let me replace that by x, okay? So replacing t and u by x. So this is here you see, by the definition, here is the Fourier transformation of f of x into, this is the Fourier transformation of g of x, okay? And Fourier transformation of this is the proof, okay? So product of the Fourier transformation of f of x and Fourier transformation of g of x. So that is what we needed to prove. So hope you have understood this. So thank you for watching. See you in the next video. Or you can add one more thing, as I have considered this one Fourier transformation of small f of x as capital F of s, and Fourier transformation of small g of x as capital G of x. So it can be written this also, it is equal to capital F of s into capital G of s. We can write this one as well. So see you in the next video. Thank you for watching.